last class, I think I already started discussing the machine learning algorithm perceptron using the sklearn package. And the example, probably let's just do a quick. So we still use the ARIS, but this time we get the ARIS from sklearn data sets. Okay, it's a similar ones. And we already know the ARIS data set. So it's regarding some flower. There are 3 classes, ARIS setoso, ARIS versicolor, and ARIS Virginia. And what we know are the known features. So known feature generally we represent as X vector. It include width and depth and length with septal, that I remember, and the pedal. So that's why there are 4 of the values for the features, okay? And for the Y is target value. So target values here are going to be the 3 classes, 0, 1, and 2. So we use numeric number to represent the classes, different classes. So this is not binary. This is going to be a multi-classification. And the sklearn, we will see for the perceptron, it supports that, and how it's going to use some technique, we will see that, okay. And also last class, we also mentioned for sklearn, generally speaking, when we do machine learning, so we first do data cleaning. So after data cleaning, then generally speaking, we are going to split the samples. So that's all samples. Okay, so in this case, we have 150 samples, etc. And for the samples, then we are going to divide it into training set and testing set. And then you can specify the ratio, okay? And you can specify, like in this case, we specify the ratio as 70% for training and 30% for testing. And normally, if you want to keep the class ratio as original, then you can specify the stratify as yes. Okay, so that's the, so if in the sklearn from the model selection, and if you call this method train test split, it will automatically take care of the splitting data into this 2 set, training set and the testing set. So that's normally we need to do that. And then you can also, after that, you can also see the, so over here, the bin count will give us the idea for each of the category, each class. And what is the next one? Normally for machine learning, we also going to do feature scaling, okay? Feature scaling. And in this example, it's not that necessary, because if we take a look, the data values, if we take a look, the data values scale, they're kind of the same scale, that not differentiate a lot. But think about like a housing price. prediction. Of course, that's not classification, but anyway, something like that. What we need to consider the features. Features may be like a square foot. So square foot may be 1,500 something square feet, is it? And the number of rooms, like bedrooms, there may be 3 bedrooms. So for some normal, ordinary house, is there? And some other features, like a number of garage or something. Then if you take a look, this square foot, this feature, and the number of the rooms, these two values, the scale is not at the same level. Is it? So it's quite differentiated. If it's quite differentiated, when over here, what we are going to use is, if you recall, gradient descent. If we don't bring them to the same scale, it will converge very slowly. Okay, so in order to avoid like the convergency, slowly, then we needed to do the feature scaling. Feature scaling. So feature scaling is try to bring them to the same scale. Okay, same scale, and what over here? For sklearn, it also belongs to pre-processing. Okay, there is a model called standard scaler. Okay, so the standard scaler is you use the mean value of all of the samples and the standard deviation. Then this is each sample's single feature. If you apply this calculation for all the samples, all of the features, then we can bring the values in the same scale, like 0 to 1, the same scale. So then after we do this, when we apply the gradient descent, it can expedite the gradient descent convergency. So to do that, then we first needed to create an object of standard scaler, okay? And then you fit, you just call the fit. You plug in with the training data. And then we needed to transform the training data's features. So this is training data, training's features. But also remember, for the testing training, this is testing's features. So both you needed to transform, okay? Because after you train with the standardized data, the scale data, and for the testing and the prediction, if you don't use the scaled, then the result definitely is not going to be correct, is it? So we need to first transform, okay? So you get the new scale data set for training and testing. And what the next one, it's pretty straightforward, okay, if we use the sklearn package. So for perceptron, it does, the sklearn linear model does support perceptron, but not adline, okay? Adline not supported by sklearn. And we have a the adline one. So the author provided adline model. So we can use that later on. We will explain that. But anyway, so for the perceptron sklearn supported, then it's also pretty straightforward because the model already supported. So you just initiate the perceptron. And the first parameter is number of iterations. Okay, because if you recall the gradient descent, it involves number of iterations. So you can specify the number of iterations. This eta is a learning rate. And this random state is you can reproduce this training. Okay, so after you create this model, then you call fit. With fit, then you plug in, if you take a look, the skilled data, okay, from the training set. So both the feature and the target, okay, feature value and the target value. So after we do this, then you can predict. So what over here, when we do the predict, we use the testing data. So also skilled, okay. Testing, then you can get the predicted Y, the predicted target values, etc. But if you recall, for the testing targeted value, so this is target values from testing set. And this Y predict is predicted target values from testing set. Okay, from testing set, and we use the perceptron model. And the perceptron, basically, internally, we already learned to use gradient descent, is it? So these two may not be the same, exactly the same, is it? So, because if it's the same, then that kind of means your model is pretty good, is it? So what over here we want to know is we want to know how many samples not correctly predicted, is it? And over here we can see there are 3 samples not correctly predicted. So that's regarding for the testing. And then normally for the accuracy score is used to measure a model's performance. Because we do machine learning, is it? So the learning, then you use a model to train. Then, but you want to know how good the model is it? So basically it's to measure how accurate it is. So over here for sklearn, the metrics package, we can also find the accuracy. Okay, and then you just call the accuracy method, and you provide a testing and a prediction. Then it will give you the accuracy. So in this case, 93%. So it's not too bad, is it? And the perceptron model itself, you can also get its accuracy score. So if you want to use that, then you just do the perceptron data score. Then you plug in the testing, the testing's feature and the target value, and you will also get the accuracy result. Okay, so generally speaking, we already see this is the simplest case. Okay, to train a model, and then you test a model. Okay, so generally speaking, the step is you clean data. clean data, is it? And then we do some pre-processing. Pre-processing, we need to do the feature scaling. Okay, feature scaling. And what next is to train the model, the selected model. Is that after that you can test the model. Is that after you test the model, then you need to collect the performance. And generally speaking, it's regarding the accuracy. Okay, so that's the general step. So you can also see with sklearn library, then it saves us a lot of work. Okay, so for the perceptron that we discussed, we said it's a binary classification. Is it? And sklearn, like over here, most algorithms, the sklearn package also support multi-class classification. It uses a technique, it's called one versus the rest method. So OVR, you will see that a lot. So it's one versus the rest. So the idea here is, here we have 3 different class, is it? So maybe this is one kind of flower, and here you have another kind of flower, is it? And here you may have the 3rd type, is it? And for linear classification, the binary classification, one versus the rest. So the concept is still kind of borrowed, like one binary is, you can suppose you first determine, like, if it is this flower, the first type of flower, is it? So what you can find is, we can find the linear separation line, is it? So this group then is the first class, and the other samples, the other data, they are not. Is it? So okay, you get the first type of flowers classification, is it? And then you can, so similar, is it? You can keep applying this strategy. Then okay, so here is a second, is it? So second versus the rest. Then in this case, all of this are not 2, is it? And this is 2, is it? So you have the classification. And then for the, I didn't draw very well here. So for the 3rd one, it's kind of like this, is it? So this is the 3rd group. And all of those then considered not the 3rd. So then it's kind of, you do 3 times of classification, is it, for each type. And then you find the best values for all of this, for each of it. So this kind of concept is called one versus the rest, okay? So anyway, for multi-class classifications, by default, the perceptron already supported, so we don't need to worry too much. So we already got the idea of the perceptron using sklearn. And I want to go back to the perceptron that we implemented, is it? Using we define a perceptron model as a class. Last class, we already explained this perceptron. And in this case, you get the CSV file from some online repository, okay? And so what over here today I also want to explain is about plotting. Okay, and we are not going to go to too much detail regarding plotting, and I have some notes, so later on I will post it on our course website. So if you want to know more detail about the pie plot and from the matplot library, and you can learn it more, okay, on your own. But we are going to take a look regarding this example. So anyway, so this XY we already know is regarding the features and the target values, is it? And in order, so later on we will see how do we do plotting, is it? Because that helps a lot for the visualization. And to do plotting, then you need to import the matplot libraries, PyPlot, and normally we do import it as PLT. Okay, so that's what we normally do, kind of like a NumPy, pandas, is it? And then what next we do is, so we first plot the data. So this is raw data. Okay, so raw data has features, as it has features. And over here, because in the data set, we already know the class, is it? They already have the class label, is it? So there we can visually using different color to represent that. So over here, because we have two features, is it? We have these two features. So one is width, one is length, something like that. So we get the first 50 samples, and we know their color. We are going to plot them as a red color, and using the marker shape, a dot kind of, and the label we call it Sept. Okay, and this plotter is a scattered plot, so all samples points will be spotted. So this kind of plotting, we call it a scatter plotting, okay? And then for the second group, it's versicolor, is it? Then you get from the next 50 samples, and you retrieve their features. And this time we use different color, is it? And a different marker. And for the plotting, we also want to label the plotting, so that you know, okay, what x-axis represent, y-axis represent. So that's how you do that. You do the x label and y label. Okay, and the legend is, because over here we have the label, is it? And the label, then how are we going to represent it in the graph? So we can do the legend, okay? And legend, you can specify the location. If you don't specify, it will pick the best one, like some empty space for you. So over here it's at the upper left, okay? So after you specify the feature of the plot, then you need to show it, okay? You can also save it. And so over here, if you take a look, that's this plotting, is it? So it uses different color, and visually, clearly, we can see it's two different class, is it? And we also have the legend. So legend, and the septal and the versicolor is from that label when you do the scatter plotting, okay? And this is called legend here. And over here, we also specify the X label and Y label, is it? And the data range is based on your samples data range. So it helps a lot, is it, when we do the visualization. And the training we already see, is it, regarding that. And in this example, it also, so it also do the further plot after the perceptron, is it? Because it can keep track of the number of arrows, is it? For each iteration, is it? So in this case, it's just do the plot. Okay, do the plot. So the x-axis, so this is x-axis. And this is y-axis. And here is the marker, is it? So if we take a look at the plotting, we can see the marker for each of the arrows, is it? Based on the number of iterations, is it? And over here, we also provide the x-axis and the y-axis is the label. So x-axis is represent the number of iterations. And the y values is the arrows. Then we show, is it? So the result, then it gave us this kind of plotting. This is just for plot, is it? And how this can also help. Why we said this is useful is you can see with the iteration going on, the number of arrows should decrease. Is it? It's correct. It's decreasing. Is it? Because if you have some result looks like this, then the model is bad. You want some model like the arrow going down with the number of iteration going on. Okay, so then this means the model is good. Is it? With the number of iterations, the arrow should going down. Okay. So that also helps, and this part I think we already explained, is it, the prediction. And for quite a number of examples in our notebooks, we also use another kind of visualization. We can plot the decision regions. And in this example, it already gave us the kind of like a template for this simple classification perceptron. And we can kind of borrow it for our future, like your assignments or the labs, okay? So in this case, we can first take a look what the result looks like. So this is the two, if you recall, the sample data, is it? In sample data, what this graph gave us, this plotting gave us is for the classification result also. And it also has the classification separation line, is it? Then we have these two different class. So it's very helpful, and also for each class region, it also has different color, is it? So how do we do this? So let's take a quick look at this plot decision regions, okay? And this function take in your sample feature data set, data values, and this is the target values. And you can specify the classifier, is it? And because over here, we just learn perceptron, is it? And adline, so you can plug in. This is resolutions for the drawing. And over here, it also, because we have different kind of classes, is it? So over here to provide different markers. And the colors over here to also provide, because later on we're going to use this listed color map, okay, for contour, so that it makes the classification decision quite clear, using different color to represent different class, okay. And then in this case, it's going to be based on the different number of the target values class. Is it in this case, we only have 0, 1, is it? So that's why you just take this. So the color then is just take, from this color set. And then what next one I try to show as we are going to, so over here we have 2 features. There are 2 features. So 2 features, it has, because you're going to draw the whole region, is it? The whole region. So we need to know the minimum value and the maximum value. So that's how this part gave us the minimum value and the maximum value of each of the features. Okay, once you have that, then you call NumPy's mesh grade to generate, because we are going to use this for the decisions coloring also. So that's why we need this mesh grade, okay, for the contour to take care of the coloring. And so we use this mesh grade to generate this two values from the feature values, okay, from the feature values. And once we have these two, so it represents 2 dimensions, okay? The 2 dimensions basically also represent 2 features. And then we have the classifier, that the model, then you call it predict, is it? And the predict, you predict with the feature values. Okay, and this xx1 and xx2, after you do the mesh grade, then it's 2 dimension, 2D. Okay, so for our prediction, we only take 1D. So that's how we call the revel. If you recall previously, NumPy array, we learned the revel is reshape. And for revel, basically, it's flatten your NumPy array, is it? Okay, so then you can call the predict. So what predict generated is what? Is the target value. Is our target value, is it? But just think about it in 2-dimensional, is it? So this is the first feature, second feature. How are we going to represent the third value? There is no way to draw it here, is it? So that's why over here we use the different color, is it? Using color to represent, okay, belong to the different region. So the top, so this is separate line, decision line. Then this is one kind of a color, another kind of color, so that it can represent the Z values. Okay, Z values kind. And here it also gave us some glimpse of the Z value. Okay, and we also needed to reshape anyway for this, because for the pie plot, we want to plot the contour. If you recall, is it previously when we discussed the gradient descent, as if you recall, we have the the convex, is it bow function, but this is just for a single feature, is it? So this is the cost function. Cost function, is it? And here is our weight. The weight. At that time, we also discussed, and if this just represents the single weight, then you can draw the cost function versus the weight relationship. But if you have two-dimensional weight, and if we want to know the cause, then we do, if you recall, the contour is it. Then this is this represents like the y values, is it, with the contour. So here kind of similar concept, okay. So we can use the contour for the targeted value in this case. And the contour then is based on x-axis, the two features and the target values, is it? And over here, we use that color map, okay, color map. And you also wanted to know its region, is it? You don't want to go beyond the minimum and the maximum value, so you can provide the region. And then you can also do the scattered plotting. Is it? For the scattered plotting, then it's for your sample data. Is it for the sample data? So this part is the same as what we previously already saw. Okay, and after, so that's this plot decision regions function, is it? So after that function, then in this case, we can plug in our features and the target, and the classify in this case is perceptron, is it? Perceptron, and then you can also provide the label and the legend. And then we are going to also show this graph. So that's the plotting we come up. So this gave us the classification, kind of like the decision surface, the contour represent your classification, okay. So this is regarding the plotting. We also kind of get some idea. And then for this part, the last example we haven't discussed is the adline. Adline, as I previously said, it's not supported, okay. Not supported in sklearn. So in our assignment, if I request you do the adline one, then you need to borrow this example. And because over here, we already created the adline model, okay? And we use gradient descent here, okay? So let's take a quick look of this adline. And it's also has a lot of similarity between this one, the perceptron one, that raw one that we created ourselves. So eta is same thing, learning rate, okay? And also be careful, the learning rate, don't get it too small and don't get it too large, okay? Normally it's between 0 to 1. And if you pick it too close to 1, then it can cause overshooting. And if you make it too close to 0, then it's converge slowly. Okay, so pick some better ones. And then this, we also have number of iterations and the random space. So that's a similar concept, okay? And the weight, that's what we try to train to find, is it? And the cost function, okay? Cost function in this case use sum of square root, okay? And it's because this is an adline model, is it? This is its constructor, pretty straightforward. And the fit part. So fit part, we first generate some random number. They're using this random number for our weight. So this is the initial weight. initial weight, is it? And the cost we are going to also record for each iteration. So over here is for each of the iteration, we are also going to log its cost. Okay, log its cost. So we first do the net input, and if you recall, it's sigma xi and wi, is it? So that's a net input. And for the net input, then we call the activation. So let's take a look at the activation function. So the activation, if you recall, for adline, for perceptron is the decision function phi, is it? It's unit step function. So it's either 1 or -1, is it, for two different classes. And for adline, because this we saw, it's not when we use the training, because the weight is either 2, -2 or 0 updates, is it? So it's not optimal, okay? So that's why we pick adline. So for adline, then the activation function phi, then it's just the net input. Net input, is it? So that's how it just return whatever, okay? And the prediction is still like 1 or -1, okay? But it's based on the activation result, is it? Activation result. So that's because this is still for classification. Okay, so the output is the activation, so for the net input, is it? And we wanted to know the errors, is it? We want to know the errors. And then we do the sum of square of errors. That's what this part does, is it? But does. And then you can update your weight. Is it? Update the weight based on the learning rate. Learning rate. You update the weight. Okay, update the weight. And here we have the cost. Is it? So this is that cost. And we record each of the cost. Okay, so that's generally is this adline model. And then we import the data set from the CSV file, is that from CSV file? And here, same thing, it's going to do the plotting, okay? And what we are going to do here is we are going to train that model, adline model, is it, with 10 iterations and 1% for the learning rate. So we call the fit, is it? And once you do this, and over here, we are also going to plot what? Plot the cost. Okay. We are also going to plot the cost function. Okay, cost function. And what over here we do the plot is not directly for the cost. We do the log of the cost. Okay, log of the cost. And we are going to see the cost versus the number of the iteration, what the trend is for this learning rate, is it? So this is one learning rate, and then we also try the second learning rate. This is quite small, is it? The first is 1%. This is 0.01% learning rate, is it? And then we also keep track of the cost, is it? And versus the number of iterations. And then we let it show. And over here, for this plot, if you take a look, it called the pi plus subplots. So the subplot allows multiple figures, because previously we just see single one, is it? And here you can also, because a lot of you want to do some comparison, is it? So you want to align multiple figures in one plot, then you can use this subplots. Okay, subplot. And for the subplots, and if you want to refer which subplot and the number of rows and the number of columns for your subplot, in this case, it's 2 subplot. Is it? One is for the 1% learning rate, and the other one is for the second learning rate. Is it 2 subplots? Okay, then you refer, okay, so this is number of rows, so it's a horizontal align because you have 2 columns. Okay, and then you just specify where you are going to do the plot. Okay, so the first one you're going to, so this is x1, is it? This is the second subplotting x2, is it? Then it will draw the plot in the corresponding plotting. And over here, and then we see the result. So this is square of the arrow, is it? So this is the log of the cost, is it? So here is the log of the cost. And for this case, learning rate case, we can see with the number of iteration going on, it's increasing. And for the second one, it's decreasing. So which one you think is a correct option? Then this one. Okay, so that means this learning rate train the model, the result is better because it's supposed to, with the number of iteration going on, the cost should decrease. Is it? Because that's our goal. We try to minimize the cost. Is it? Because if the cost is smaller, that means your prediction line is very close to the 2 different class. Is it? Pretty close? Otherwise, your line is like this, then the cost, of course, is going up. Is it? So with the iteration going on, the cost should decrease. Okay, so always keep this in mind, okay, in machine learning. So that's kind of for the gradient descent, it's the basic idea. Okay, so then after you train the model, then you can also use the model to do prediction, etc. So we can predict. So with the prediction, then you can specify certain X value, and then you get to the predicted result. And we can see the prediction also quite a good result. Okay, so that's the adline example. And so we complete the study of the first unit, okay, and Wednesday we will start the next unit.